resilient, sustainable cities in Turkey at the earthquake zone. I just want to thank to everyone here because of their efforts and their time. We will have two presentations from Nils Larson and from Christian Vidic-Girel. Thanks to them also. I want to thank them also. Then we will have a closed session together in order to organize the workshop which we are planning for the end of April. And hopefully we will be together to discuss the international experience and what we can do further in order to heal the disaster which we faced. Thanks to everyone. I have a very short presentation just to remind what we had. I will do that, then Nils Larson will take the stage. Let me share my screen. It is just a reminder. For that reason, I will keep it very short. Actually, we have some live faults in Turkey, and the East Anatolian fault was bringing the disaster to us. And as you can see, our earthquake zones. And it was not the first earthquake which we have the damage. So we need to learn to live with earthquake. And we had two really big earthquakes in just 4 or 5 hours period. And you see 11 cities of Turkey has been affected. And after the earthquake, we were there, but what we have realized was really very bad. Now we are trying to heal our illness still, but we have lot to do. We had a small scale model in Izmir in 2020, but the photos are very similar. And according to lots of different experts in Turkey, our regulations can our regulations are okay if you just take into account what we faced during the earthquake. But still we are losing lives, and according to the government, it is more than 50,000 people. And these are some images from 1,900 years ago. And it was the same earthquake at the same region. So we know that we are facing it every time. And we have some ruins at the earthquake zone, but we don't want to have it anymore. And if you think about Göbekli Tepe, which is very close to the earthquake zone, we have to understand how to have resilience, because 12,000 years ago we did this in this region. And we are dealing with temporary shelters right now. I'm trying to understand what we can do to have temporary shelters, and we are trying to assess what different countries did. And for that reason, these presentations will be very beneficial for us. So I just want to leave the stage to Nils Larson. And please, Nils, this is the third meeting which we are having all together in order to get an idea about what we can do. And Nils Larson is a very important actor there. So please, Nils, the stage is yours.
Okay. Thank you, Ilker. Am I on audio? Yes?
Yeah, we can hear you. Right
okay,
now.
Okay. And I'll share screen if I may.
If you want, I can share, by the way.
Yeah, okay, fine. So we don't see mine yet. There. Okay, we're on. Oh, that's the one you put up. And I think
March 20.
Yes, but yes. All right.
Do you want me to go on?
Yeah, all right. Well, hang on, just go a few more slides ahead. A few more. More. Another one. Yeah, okay, so this one is fine. Okay. So I will not present the first stuff, which is similar to Ilker's, but he's got more real information in his description of the earthquake. Now, can I take control of this now?
You have to tell me this.
Yes, okay, let me take control over the file. I can't control it yet.
I guess if you can share, or if I'm going to share, you have to tell me to go the next slide.
Well, okay, no, previous slide. I just wanted to check that this was the previous. Okay, so
Starting
here,
from here?
let's start here. Yes.
Okay.
And full screen. The full screen, yeah. I mean, okay. Yes, I'm Nils Larson. I'm an architect, an old architect. I have experience in concepts and projects for high performance buildings, and in scenarios for planning in small urban areas and for buildings with really support sustainable construction and sustainable development. Not that a building by itself can be sustainable in my view, but there we are. But I have no experience in earthquakes. Let me say that right away. So this is meant just as a kind of theoretical introduction for what I think the situation calls for, because I've been looking fairly closely at what's been happening and also at some of the previous experience of earthquakes. So next, please. Are we there? Yeah, excellent. So this is actually a word table, and I'll send that. If I haven't sent it to Ilker, I'll send it to him again. But you can see the way I've set this up here is to say, to compare what system are we talking about? Can you scroll up just a little bit? There, thank you. That was fine, yeah. What's this? No, leave it up a little bit. Hello, this, leave it there. No.
Is it?
You have an itchy finger. Up a little bit.
Up, okay.
There, thank you. Basta, finito. Here we have what is it applicable to? And the next column is rapid rebuild options, and then sustainable reconstruction options, and what standards, methods, tools, and training are applicable. So this is pretty theoretical stuff. And a lot of stuff, of course, has to be, like anything I've done in my career, it's a generic toolbox, if you like, and it has to be applied to Turkish situation. And it's probably quite different in each earthquake zone as well. Can you go up just a bit, because I'm missing something at the top here? There. Okay. So for residential, can you reduce it just a bit? There, thank you. Excellent. Here, yes. we need mutual cooperation between technical schools to provide courses on reconstruction. You see, most of this is really applicable to the next earthquake, not to this one. Except here, we start getting into more tangible things. Undertaking a triage to sort materials and equipment for reuse, recycle, or rubbish. Use a structural and mechanical engineer to make on-site certifications. We did this in a program I ran in Canada for high performance buildings, which included an emphasis on reuse of materials and equipment. And we had a couple of projects where we had on-site engineers who inspected the components and certified them for reuse right there. So it was a very quick process. And then we need storage facilities for sorted materials and equipment. Use sorted and useful materials to build temporary covers, shelters, warehouses, etc. Now, you know, this is not rocket science. This is just an obvious thing to do. And the process is, the method is preparing an inventory. Then the next chunk here is temporary shelter. No, not leave it. No.
Okay.
Thank you. Thank you. Thank you. Temporary shelter for residents of damaged or destroyed residential areas or buildings. That can be, and this has been tried out in many earthquakes and disaster zones, camping caravans or construction trailers, site assembled temporary shelters, or building small, very small houses. And I said Georgia Tech here because I know that one or two of my colleagues on this call have been in touch with Georgia Tech University about very small houses. And you can see here again, the sustainable reconstruction options are, what do we do with the temporary units after rehousing? We don't just throw them away. Do we establish companies or organizations to lease the units for the next quake? Or do we mothball after use for future quakes in warehouses somewhere safe? I mean, each one has different financial penalties or benefits. Site assembled temporary shelters use on-site materials in the short and long term to build temporary units. Donate units to victims. I put a question mark there because that's a kind of socioeconomic decision that brings in who is owner of these temporary units anyway? Is it the government or is it nonprofit organizations? Or disassemble and reuse the components after the use. And the same thing here, disassemble and reuse in new locations, or integrate with permanent houses. If you can build very small partial houses and turn them into bigger permanent houses after the earthquake is over and after the owners want to come back and rebuild in a more serious way, that could be a good use of the first small shelter. Or transport and reuse as temporary housing units at the site of the next disaster, or as elements for a new purpose, such as canopies or sheds or small warehouses. And there are some things here, standards, methods, tools, and training. We need to assume at least a 5-year lifespan. Somebody was talking early on in this process about a 2-year lifespan, but I think there's general agreement. You have to look at least 5 years and possibly 10. Provide photovoltaic power, of course, on site where possible. We have to modify some of these, like construction trailers, to provide sanitation on board. And we have to provide on-the-job training so that local residents can assemble shelters. Then if you move over to the right, residential development projects, in other words, low-rise housing in projects or multi-unit residential buildings, high-rise even. And the rapid rebuild option is to rebuild or repair on the same site. which is not a very good idea in the long run because you're in a vulnerable zone, and it would be better to be out of that particular zone. And what I'm saying here is we should reconstruct for a more sustainable reconstruction option, reconstruct as close as possible to the original location, but in a less active quake zone. And you have to consult geotechnical experts because each earthquake zone is different in nature. And here, for a more sustainable long-term solution again, even if we're talking about low-rise projects or mixed-use projects, we want to ensure a mix of residential, commercial, public, recreational, and ecological zones to optimize land use and to reduce car use and commuting. That's a big, a big goal in sustainability urban planning, to reduce the use of private vehicles in and around the zone, because private vehicles occupy a lot of land space for roads, for parking, and also create local pollution, of course. Maximize use of renewable PV energy on site and on buildings. Now, consider synergy zone approach. I have something that illustrates what I mean by that. This is something that we've looked at in Canada, where you look at small clusters of buildings with very different occupancies and configurations. That means you can have efficient exchanges of surpluses and deficits in thermal and solar energy and gray water. I'll show you a diagram later on. Optimize building layouts to maximize winter solar access and photovoltaic exposure, and optimize summer airflow through ground area. We're talking here now about not so much the building, but the layouts of the buildings and the design of the ground surfaces. Minimize heat island effect by increasing reflectivity and permeability of paving on streets and public areas, and by increasing tree coverage. None of you who have the slightest contact with architecture or planning will be surprised by any of this. You've seen all this before, and I'm not inventing anything new. I'm just really putting it up on the wall and saying we have to look at these things. And only one thing you may not be used to here is SN tool. That is a Excel-based tool, or rather toolkit that we have that can be modified to suit different small urban areas and be very helpful in establishing performance targets. And that would be a very good thing to do in this case. And you see down here, SB tool, that's for the buildings side. We have two basic toolboxes, if you like, done in Excel. This is now at the bottom right hand. This section is on multi-unit residential buildings or apartment buildings, 1 to 3 floors, 4 to 11, and 12 plus. The quick and easy solution, and not the best solution at all, is to rebuild or repair on the same site with the same footprint, orientation, unit type. This should be really avoided. And even if you do this, you should at least ensure a high degree of structural integrity for earthquake zones through application of updated standards, design, and supervision. I keep hearing from various colleagues who have experience in Turkey that supervision and quality control is a major weakness, even though the actual earthquake standards, the structural standards, were pretty good. And in terms of, for multi-unit residential projects here, a more sustainable long-term solution, again, like on the previous one up here, reconstruct on the site as close as possible to the original location, because people don't want to move away from their homes, really, but in a less active quake zone. And again, consult a geotechnical expert. Optimize orientation, window types and areas to provide trees and landscape to reduce summer heat gain. You don't want windows, whether it's Turkey or Spain or Canada, you don't want big window areas facing southwest, for example, because it provides too much solar gain in the spring and summer. Use natural ventilation. And of course, a lot of big companies that come in and want to rebuild for the local population, they would like you to use mechanical ventilation systems and air conditioning, HVAC. And really, an HVAC mechanical system should be avoided to the extent possible if you can use natural ventilation with openable windows, exterior shading, and that saves you a lot of energy right away. And again, maximize use of photovoltaics and other renewable energy sources. And again, ensure a high degree of structural integrity through updated standards, design, and supervision. Reuse materials where possible, and that comes back to the beginning about using on-site engineers to inspect structural elements and see and determine, can these be reused? And consider also use of heavy timber and or light wood construction. Next, please. This is not finished, this is just sketched out. And this I've started doing, but here I really need to work with engineers, or whoever does this needs to work with engineers, but in the same kind of format. What's the quick and easy and short-sighted solution, and what's a more sustainable long-term solution or series of solutions? Next. And here, the main part of this file, I've put it in text terms and split it into urgent actions, midterm, and long-term actions. And the urgent ones include identify priority cities and urban zones for reconstruction. In each priority area, identify key community buildings that have to be built or repaired or rebuilt, by specific types. Identify number percent of population and household types who are without shelter and who remain in affected areas. And so that determines really how much do we need in the way of shelters and housing units over the next 5 or more years. Also, make sure that owners of destroyed properties will be able to retain title to their properties. And that is not the easiest thing to do when there's been total destruction. And that's already happened in Ukraine, I believe. Next, please. One of the urgent actions is to establish a skills registry to identify individuals and firms in sensitive regions, in other words, quake regions, with proven skills and expertise in key areas related to structural integrity, safety systems, recycling and reuse of materials, reconstruction, testing and commissioning processes. You really have to test some systems before you release the building for use. One idea that's come up in discussion with colleagues is to launch an international multi-stage, and this was Oliver Drerup's idea originally, to launch an international multi-stage competition for design and construction of temporary housing areas and units, taking into account the factors already identified. In other words, small temporary shelters, or build them onto existing ones. The next one, identify types of housing units that could quickly be made available for occupancy. Cost, origin, main materials, also using demolition waste, hopefully, design suitability, disassembly, and reuse. Because when we build quickly in this urgent phase, we want to recognize that we may not be building it in the way that suits the long term. So we may have to disassemble and reuse part of it somewhere else. Consult with representatives of wood frame industries in Finland, Sweden, Poland, and Canada. I mean, there are others as well, but these are some of the main ones, to develop plans for wood frame buildings that are suitable for small housing and education or commercial functions, that are easy and quick to build and to disassemble, and then can be reused for new purposes. Next. This is, well, first A10, segregate demolition wastes and identify through a triage process those that can be used as building materials or energy resource or other resource. And A11 is an idea that was proposed by Kajetan Sadowski to use some of the debris to build these, what he calls waste walls, which seems to me a good approach to try to reuse the existing debris to be part of new structures. There are perhaps some sensitivities about using debris that may have been from buildings where people died, but I don't think that's going to happen very often. Next. Medium-term actions. Repair or replace damaged or destroyed key public infrastructure, including power plants, district heating plants, and water and sewage treatment facilities, railways, railways and key roads. Upgrade structural and energy performance of existing buildings, including improved earthquake resistance, building envelopes, and glazing. This is, here again, the longer term, a better thermal performance of building envelopes and glazing also. Where new buildings are required, they must be designed and operated to very high performance, near zero energy standards. Next. Oh, and here, I've mentioned here that one of our colleagues, Umit Unver, has helped to establish a zero build organization in Turkey. And that should be a good source of information in the long run on this subject area. Next. This is what I'm talking about, the synergy zones. Where you have clusters of new buildings, a cluster of 6 to 12 to 15 buildings, let's say, that are located in close proximity, if you start to look at the surpluses and deficits, for example, an office building usually has a surplus of thermal energy, and an apartment building usually has a deficit of that. A school has a surplus of gray water from large roof areas, and an high-rise apartment building or high-rise office has a deficit of gray water. So there are things that can be matched here to make for a synergistic solution. And that can result in considerable energy and cost savings, although there are management barriers here where each individual building belongs to a different organization. Next. We have to, again, obviously, rebuild and repair road, electrical, communication, gas, water, and sewer systems according to the needs of sustainable urban development plan, with an emphasis on supporting the quality of urban life, reducing energy consumption and greenhouse gas emissions, improving public transport, and minimizing use of private vehicles. No matter what country you're in, people love their cars. And we have to really, for long-term sustainable solutions, get people to leave their cars and use public transport more. But for that to happen, public transport has to be really available and really high quality. I, for example, have, my wife and I got rid of our car 18 years ago. We live right downtown in Ottawa, use bicycles, buses, rental cars, and a loan car. We have a person who we exchange, it's a circular economy kind of thing, where we pay a little bit each time we use her car. It works very well. Establish and maintain databases of operating energy and emissions of buildings and other structures. Launch training programs for individual workers in small companies to develop skills in high quality and energy efficient construction. In the case of residents who are rebuilding their own homes, which may be in a scattered way, provide small teams of traveling professional support advisors to support these efforts. Launch training programs for inspectors who are mandated to certify conformance to construction quality and operating standards. This is, of course, hugely important in Turkey to make sure that our buildings in Turkey don't fall down so easily. Next. Long-term actions. Develop plans for urban areas using maps showing changes in active fault zones so that most sensitive areas can be avoided. Identify demographic trends in likely regions that may affect reconstruction plans. Develop plans for rebuilding a sustainable, safe, and low-emission, healthy, resident-friendly city while also respecting traditions and cultural heritage. This is motherhood, if you like. I'm sure there's a Turkish word for motherhood statement, but it's necessary to say. Develop strategies and plans for sustainable neighborhood reconstruction that follow low carbon and green principles while supporting local employment and providing safe, healthy, and comfortable environment for local inhabitants. Another motherhood statement which is necessary to put on the table. And don't forget, minimize storm, flooding, and wildfire potential, because we are in an era through climate change where we have more storms, more flooding, and more wildfires in many cities around the world. Next. Allocate land that will remain surplus for leisure, aquifer replenishment, urban forests, wildlife, and biodiversity. There's a temptation to reuse land that is temporarily vacant for profitable reconstruction, and that's not a good idea. Develop new infrastructure for low temperature district heating systems to replace high temperature. Now, you don't have much of that. This paragraph actually I developed it for the work, similar work we're doing in Ukraine, where there's a lot of high temperature, very inefficient district heating systems. And I am not sure actually how much in the way of district heating you have in Turkey, but if you do, then we have to have for the long-term solution, low temperature and efficient district heating. Identify the capability of reconstruction plans to generate local employment. That's another factor. You don't want a lot of outside labor force to come in and build it and leave the locals without work. Minimize use of non-renewable materials in new construction and make effective use of recovered materials for reuse or recycling. Next. Okay, this is a reminder. Each day we delay, and this is the climate change reminder, we have to reduce our emissions drastically, quickly, because otherwise, and the 1.5 Celsius target, of course, is an average over sea and land, and in fact, it's going to be much higher over land. So I think that's it. Or one more. Oh, no, a couple of more. Oh, these are appendices. Okay, one, let's have a quick look at this. This is an Excel tool we've developed, which is not yet ready for prime time, but it starts to sketch out. Next. Next. You can see here, the idea is it deals with what kind of asset or component are you talking about, and you can click on the blue boxes to pick from a predefined list, and then you can say what is the damage level, and what are the here, for example, what are the actions required, and what's the priority, and then an estimate of the cost. And that is, as I say, it's sketched out, and we hope to get some serious help in making this a real tool that can be used in both here and in Ukraine. Next. Okay, next. Oh, that's interesting. I think that's it. I think, yes, sorry, I did have a slightly later version of this, which had finished this up, but that's it for now. You can see it's a work in progress, and I hope it's of some use, and I will, of course, benefit from the comments in this session and keep working on it. Ilker, over to you.
Thanks a lot, Nils. I know what you are dealing with for too many years' time, and you just showed some examples, and I'm pretty sure that it will be very useful for us to understand what we can do and when we can do, with whom we can do. So I'm really waiting for the workshop and the seminar series to get an idea about what we, as a group of people here, sitting together, we can go for. Thanks again. And now, if you are ready, Christian, the stage is yours. We can listen what you have done in Chile. So it is it will be a very interesting topic for us. And everyone in Turkey, believe me, really wants to hear from your people, your style, because we know that you deal with earthquake very well. So hopefully we will have a chance now. Thanks. Whenever you want, you can share your screen. Your microphone is off, by the way. Christian,
can you hear me?
Yes, now we can hear you.
Okay. Can you see it?
We can see it. It's on the screen right now.
Okay, thank you. So first of all, I want to say thank you to Nils. Nils, your work is wonderful, and it's a very, very, very important, and it will be quite useful in Ukraine, and as well, of course, in Turkey. So thank you very much for this very special and avant-garde point of view related with the understanding of devastated cities and how to understand the best measure to evaluate what is the best way to reconstruct it. So thank you very much for this, Nils. So, and also I want to say thank you to you, Ilker, for inviting me to be there, to be here today, because, you know, yesterday occurred a small earthquake here in Chile. You know, we are so, you know, related with, so it's just you know, a little bit, etc. But this sensation, this secure sensation related with a small earthquake 5.6, it's the result of a huge experience to build cities. People feel themselves safety in our cities now after a lot of earthquakes experience. So, well, very, very good morning to all. First of all, I want to extend my condolence to the Turkish people for the victims of this latest terrible earthquake, especially to those who are with us today. This is the first thing. So believe me that I understand you very much because I am Chilean, as I already told you. And our history and our people have been forget in fire, forged in fire by earthquakes and tsunamis. So please receive my condolence about this. So the final name of my presentation, it's related with our experience to be more to build the more mitigation, and also to transform in a resilient cities, our cities. So I am Christian Wittig. I am an architect from the Pontificia Universidad Católica de Chile, an urban planner from Architectural Association School of Architecture in London, UK. And now, at the moment, we are working intensively on the development of 9 architectural projects for the reconstruction of cities of Irpin and Chernihiv in Ukraine. So, where I had the opportunity to work during June of the last year together with its authorities in the city of Irpin. And due to this extraordinary experience, I knew Nils first, and through Nils, knew Ilker and the Turkish people. So our thought group team has extensive experience in developing reconstruction process for the cities devastated, especially by our earthquakes and tsunamis. And from this experience, we want to contribute for your process in this moment. So the first question is, why Chile? Why this very far and very unknown and very sometimes poor nation? So the answer is very easy to explain. First of all, we has been a very tough country. We are a very stretched and long country in the extreme of the south of our planet. So we are a very thin territory, stretched by ocean, the Pacific Ocean and the Los Andes Mountains. So we have a very extended desert in the north, a very Mediterranean zone in the middle of the country, and a very cold south, very near to the Arctic Pole. So in this sense, we are in a very strange position because we are surrounded for thousands of volcanoes, mostly active now in this moment. And also we are put on the Nazca plate and the Antarctic plate, at the same time. So this is the name of the Ring of Fire, as you probably know. So these explosions graphics appears like the presence of volcanoes which is a very, how can I say, a very, how can I say, explosive mixture of things in order to understand our life, our history as a country, you know. So when the Spanish conqueror arrives here in Chile, they didn't find any gold, any silver, anything, just earthquakes, a very brave, you know, Indians here, and also tsunamis. So this is the forget country or something like that, you know, for this time. So the answer to the why Chile is Chile by far is the most seismic country in the world, record on which we are not proud at all, of course. From 1570 to date, he has suffered, resisted, and survived 108 big earthquakes and many great tsunamis. Chile has the record for the largest number of severe and extremely severe earthquakes among all seismic countries around the world. Chile has the highest number of record severe earthquake above 8.0 grades. Chile has the record of having suffered and survived the largest mega earthquake recorded in human history, Valdivia, 1960, with 9.5 degrees and 10 minutes long duration, together with a great tsunami that devastated more than 1,000 kilometers of our national coast, and which killed people even in Japan. So its large registered earthquake were in 2010 with 8.8 degree, in 2014 with 8.2, and in 2015 with 8.4. So this is maybe the most important point about this argumentation. Chile between 1906 and 2016 has suffered, resisted, and survived 78 earthquakes over 7.0. No. That is in 110 years. It has suffered major earthquakes every 1 year and a half. Less than 1 year and a half, we has been, you know, fight against earthquakes. So, well, this is a very nice picture in which you can easily see the occurrence of earthquakes and big earthquakes and related to the main zones of this earthquake. So the red circle involves Chile country and also Peru, you know, in the north. So this is a brief history of our big earthquakes, you know, during all of these years. So in blue color, you can see earthquakes above 8.0, and in the red one, the mega earthquakes, which already had. You know? So the list is huge. So this is a very, you know, easy formula to understand the seismic evaluation of risk, and in which Chile is in the first place. You know? It's not about just sensation, it's about science. You know? So as an average, 109 earthquakes, you know, between 1570 and 2016, 25 earthquakes above degree 8.0, and 84 earthquakes above 7.0, the largest mega earthquake recorded in human history, Valdivia, 1916, with 9.0. So this is the comparison of recent and historic earthquake by energy release around the world. So if you can see in the first place, the maximum energy realized was Valdivia in 1916, and here as well, Chile in 2010. This is a very good and very easy, very clear graphic in order to understand our experience related with earthquakes. So this is a very easy, very simple graphics about our biggest earthquakes registered related with degrees and death, the evolution of dead people, the evolution of damages, buildings, residential, and also the collapse, which is a very important difference. You can have many houses and buildings and infrastructure damage, but it's quite different when you have 1,000 buildings collapsed. So this is one of some experience related with this evolution, And another very important point, if you compare with human lives, is the economic cost produced by the devastation of the earthquakes. So here is, the average of that. Wow. So this is a very nice colored thermal graph of released seismic energy. You can see on the right hand the energy liberated, realized by the big mega earthquake in Valdivia 1906 and in 2010, and you can see the difference of these terrible experiences. So this is another graphic, which is very important. As your country, Chile is a very tsunami-affected country. And this is related with the Copticura earthquake, big earthquake in 2010, 8.8, and the energy, realized by the tsunami. So the first answer is the reason to pay attention to look at Chile as a benchmark. Is it only statistical? No, of course. It is not the only reason. These statistics are just facts of reality. The answer is very simple. The key issue about recognizing the facts is to understand as quickly and efficiently as possible what should be done with those specific facts. So here is a comparison, very close related with the dates. The big earthquake in Chile, 1985, and the numbers, degrees, death, damages, and economical costs. And if you compare, related with the degrees and others, statistics numbers there, that the big earthquake in Mexico City, 1985, it's huge if you compare with the earthquake in the same year with the Chile and the same, intensity of the movement. And then your very sad earthquake in Izmir in 1999, and the comparison related with the cost, the victims, and the damages. So the difference is huge. Here is another very useful and interesting comparison between the mega earthquake in Chile, 2010, which is the most recently earthquake here, not the most recently, but the big one recently here in Chile. And the comparison with the earthquake, the big earthquake in Haiti, as you can see, the difference of the degree intensity of this movement was 1.8. So this is an exponential difference. And you can see the results of the victims and the damages. And, the most important may be the economical cost and also the collapsed buildings, in this area. And in the last place appears your very sad last earthquake to 2023, and degrees and etc. And you can, comparison. These numbers was provided by many sources. So this is an average related with victims and buildings, damages buildings, and economical probably cost of your last earthquake. So what has Chile done to make an exponential difference in its mitigation results and urban resilience in the face of huge earthquake and tsunamis with respect to the rest of the seismic country in the world? Why? What is the meaning or the reason of this huge difference and the evolution through the time? If you analyze all the earthquake history. So essentially, Chile has done 4 strategic things to involve exponentially in its resistance and constructive resilience. First of all, the development of a powerful, multidisciplinary, and interconnected seismic regulatory body. This is the first thing, which is rigorously reviewed and continuously updated through collaborative work of the public and private sector, the academic world, and the political world as well. So this is the first. Our seismic regulation started in the big earthquake of 1928 in Talca, in the south of Chile. So in this earthquake, people, would understand that we need rules to, face on of the earthquakes. So the idea is how, to build through the time and to update and to review it constantly, this regulation seismic body. So second, the construction of a powerful, very effective, and very efficient institutional guarantor, powerful core. This is maybe one of the key issues about our experience, So you have the mixture of private sector, institutions. You can ask for help. You have public sector with all corruption and etc., but supervising, for private sector in some way, and the inclusion of some universities institutions in order to make labs, to analyze and understand the qualities of the materials, construction materials. So the possibility to make a certification of it, this is another thing. In the third place, the constitution of an independent academic corporations, as I already told you, linked to the best national university. This is a very key issue, the independence of this institution in order to avoid corruption. Corruption will be always, accompany us in any places. But when you invited many operators or many people, you can be reviewed for more points of view. So it's more complex. corrupt, this process. And in the fourth place, the formation of high quality technical and professional teams in each of the country's municipalities. In our country, the council, the municipality, is a key institution in many sense, but in this sense is the key factor. Municipalities, granted construction permissions, here granted the review of the structural project and the match with the architectural project as well. So you must to understand that in municipalities in countries around the countries is the key issue to face on, and try to ensure that protocols and materials, certified materials, and structural projects and also architectural projects are okay and they are ready to be built. So this is more than, in terms of reviewing many things as a summary, this is the 4 factors, main factors. So if we go forward, we have a philosophy and a strategy philosophy related with seismic issues. And the first point is design of buildings designed to resist large earthquakes, suffer damages, but never collapse. So during a useful life between 50 to 70 years. This is the main object of our design philosophy strategy related with seismic. So building has to resist, with damages, but never collapse. So a structure can be damaged and even have to be demolished after the earthquakes, but ensuring that your structure will not collapse during a severe earthquake. Third, establishes a balance between a construction cost that protects against collapse and a low probability of an extremely severe seismic event. This is the equation. A building cost which ensure you that never collapse. And also, that the probability to the occurrence of big events against this building is, this equation. But you never. I am showing you that your people in Turkey never thought that an earthquake like 1999 will be happening again. So now we are. So in the fourth place, this philosophy guaranteed the preservation of human lives, on one hand, along with optimizing the use of society economic resources. So this is the balance here in Chile in order to avoid corruption of the construction processes and also protect always the human being life. So there are 2 concepts related with structure projects here in Chile. 2 very key concepts to be protected. They are, of great importance in Chilean seismic design: lateral resistance and ductility. These 2 elements. Lateral resistance refers to the horizontal resistance capacity that a structure is capable of developing before collapsing. Ductility reflects the energy absorption and dissipation capacity that a structure can offer before collapsing. The structure must, in one way or another, dissipate the energy that the movement of the ground managed to transfer during an earthquake. The most effective way to carry out this task during earthquake of great severity is by deforming lateral and experiencing local deterioration of the material in which energy is converted into heat. Certainly, this deterioration implies internal damages, of course, but never collapse. If during this process, it is not possible to develop the horizontal deformation that leads the structure to its collapse, it will survive the seismic event. Otherwise, it will collapse. The maximum deformation that the severe earthquake demands of a structure is expressed through ductility, which is the coefficient between the maximum deformation and a reference or horizontal deformation, yield deformation. Seismic experience indicate that to have a satisfactory seismic behavior, the design must ensure that the structure has a high lateral resistance. If it does not offer a ductile behavior or a sufficient ductility for the lateral resistance with which it has been designed. So, as the structure is designed with higher lateral resistance, the lower the need for ductility and vice versa. Both features involved in the design are related, and the collapse that occur are generally associated with poor ductility, provision for the lateral resistance that has been considered in the design. This has been added to the other factors of core regulation and warranty institutionality, the great differentiating elements that largely marks the success of Chile in its process of mitigation and urban resilience in the face of severe and extremely severe seismic events. The Chilean experience, which until now has different from that used in most countries in the world, has chosen to provide high resistance and low or moderate ductility. This experience has been very successful in the face of severe seismic events, such as the one that occurred in March 1985 in the central zone of Chile and in the great earthquake of 2010 in the south central zone of the country. And as a conclusion of that, on the contrary, the method of providing high ductility associated with a low or moderate lateral resistance, as advocated in countries such as Japan, Mexico, New Zealand, USA, and many others, has turned out to be very ineffective. So this is science. No? So another thing related with the development of a power multidisciplinary and interconnected seismic regulation body is the effort to analyze the territory, over the big experience related with earthquakes in the past, in order to understand zones, seismic zones in the country. And through this classification, related with the territory of the earthquakes in Chile, try to classify the different grounds, soils existent in these zones. And from this experience, translate immediately to the structure calculations, because the foundations, this very specific zone in which buildings, get resistance by the ground is maybe another key issue of our seismic regulation, that respect that when you are, try to build some building in some parts of Chile, you have to review the regulation because it's so different, from another parts of the same country. So we have different qualities of soils, and we have different solutions for foundations in that soils. This is This is another key issue which appeared in that evolution process related with seismic normative. So this is related with the construction of powerful, very effective and efficient institutional warrantor, a powerful core. No? First, the INN, which is an institution, related to produce regulations about everything here in Chile. But this is the main institution to produce seismic regulation after a big process of discussion between, social parts, engineering college, architectural college, many other groups of people related with seismic, resistance strategy. So when INN, has a new normative or a new regulation, immediately inform the Ministry of Housing and Urbanism and also the Ministry of Public Works in order to transform, these studies into law, into regulation, effective regulation, and then go to the National Congress to be law, but also inform it to the Comptroller General of the Republic, which is a very powerful institution here in Chile, in which its roles, the main roles, is to obligate to comply every regulation here in Chile. So, for example, let me take a moment in this point. In the big earthquake, 8.8, in 2010, only 40 buildings collapses in the whole country, only 4. And this was because many things, but the 50% was to not respect the soil and ground, classification to be founded, first of all. And then another 50% not respect these two sentences related with the lateral resistance and ductibility. So all the people, all the professionals involved in these collapses buildings are in jail now in Chile. Because from these 40 collapsed buildings, only 8 people died. And one of these 8 people was a friend of mine. So I know in a very close way this history. But in Chile, law is the law, and law is very powerful. So this is a part of our culture as well. You can, corrupt many laws, economical laws, maybe criminal laws, etc., but never touch the law related with seismic and earthquakes and tsunamis. So the majority of the victims of these earthquakes, this tsunami in 2010, was because the alarm to inform people that came on the big wave from the ocean was the only reason that these victims was killed. It's not related with the buildings. It was another things that, and all of these people related with this false alarm are in jail now. So the another part of this this strategy or this structure related with the regulation system is the municipalities, which I already told about the needs that you must put a very qualified teams of professionals in order to review and make compliance about this all the things, protocols and process related with earthquakes. So, and also this is another very important part, the independent certifying institution for materials, from universities. Here, the two more important universities, more known and more prestigious university, which is Pontificia Universidad Católica, which is my university, and the Universidad de Chile. Both of them have a laboratory and a very strong and powerful institution to certify materials for the construction. So if you want to use some material, you have the certified and present to the municipality before to start the construction. So all the materials here in Chile, all the materials, piping, steels, concrete, cements, everything, bricks, etc., has the formal scientific certification. Okay? And both Universidad de Chile, Universidad Católica, complete independent, very related to the academic issues, not the politician issues, not the government issues, not the private issues. Very independent. This is another key factor related with this team. So in a very fast way, this is the organization of our regulation system related with the seismic is in Spanish, but I already told you more or less about this. And the evolution of our normative from 1928, 1935. And if you can see, any update was after a big earthquake. So the strategy to use each earthquake to, again, review the regulation system normative is a compulsory thing. And it's an opportunity to improve this regulation systemic body, all the time. And even with the international experience. For that reason, I really want to visit you in Turkey as soon as possible in order to understand many things, because pictures and videos is not the same to understand this. And to understand what is the requirements or the specific needs related with the the regulation seismic body that you need. So this is another revolution, and the last one during modifications and evolution of each core normative, all related with law by Congress and supervising by this very controller national regulator. Okay, so the conclusions. From the seismological point of view, one of the most valuable lessons that the earthquake teach us in related to the information that allow us to evaluate the behavior of our buildings or a natural scale against real loads. Give priority to the management and application of the concept of lateral resistance and ductility in a structural calculation process. Historical buildings in Chile have been increasing their good performance in the face of the different events that have occurred in the history of our country, mainly due to the improvements and advances that are being generated in design and construction regulation. The regulation in Chile had been in constant evolution through a process of continued improvement over time, but many actors, so different and from different spaces of our society. Okay? So the construction of a profound national seismic culture, which begins in primary education with a transformation in the demands placed on students of architecture and urban planning, fostering a close relationship with the structural engineers. So this match is very important in order that architects can preview that their designs are previously or preliminary related with the rules of the structural projects or something like that. So avoid or make the possibility of corruption in the construction process as complex as possible, as I already told you, forcing the involvement of many independent actors, independent reviewers, academic institutions, material certification laboratories, technical quality bodies in the municipalities, and a general control entity that oversee for unrestricted compliance with these procedures. And also I want to read you briefly some conclusion that we made with our team at the final of the construction of this presentation, which is a brief, because many things are out of this presentation. So here is. So truth be told, you need to rebuild and house hundreds of thousands of homeless people as soon as possible. This is true now. That is the top priority now. However, given the devastation directly produced by the collapse of tens of thousands of poorly constructed and poorly founded buildings on land that was not respected, and that clearly the construction processes and protocols were not respected or carried out, and that this is due to multiple factors where corruption probably plays a large role. You urgently need to develop a work process to review, update, improve, and empower your seismic regulation body, and review, update, improve, and empower the existing warrantor institutions in your country. All this taken into account that is urgent and very necessary that you build a deep systemic culture in your society, something that gets into your DNA, so that something similar never happens again. Each of you being the first warrantors and inspectors, extremely jealous of compliance with the new, modern, and updated seismic regulation of the institution that ensure compliance, the universities institution that will help independently to classify and certify the quality and systemic functionality of the construction materials, and of the construction of independent reviewers who help in the in-depth review of architectural projects and mainly structural calculation. To help you develop this process, our team is ready and prepared to advise you on everything based on our extensive accumulated experience in mitigation and resilience for our cities faced on earthquakes. Because cities must be refuges for the life and happiness of their inhabitants, and not treacherous and deadly traps. So thank you very much indeed for your attention.
Actually, I want to thank to you, Christian. It was a very interesting presentation, and I'm pretty sure that we have lots to learn from you and your colleagues. I took some notes, and it was really incredible. In 2010, you said only 40 buildings were collapsed, and only 8 people were lost their lives.
In these buildings, the majority of the people was killed was for the tsunami.
And
not for the collapse of the buildings.
And it was 8.8. So we really need to learn a lot from you and your country, your experiences. And as far as I understand, your law is very powerful, but maybe it is very important here. You said lots of people are in jail because of not obeying the rules, etc. And I'm pretty sure that my colleagues will be very happy to hear and understand what's the difference between your country and our country. So if we can have the workshop together and the seminar, probably you will have lots of questions from civil engineers, not only from architects also. So, and it will be very interesting. But Nils wants to add something, I guess. Please, Nils.
I just want to congratulate Christian on an excellent presentation with
Thank you
a
very
lot
much indeed.
of in-depth information. Thank you very much.
Mhm.
Thank
Yeah,
you very
it was-
much indeed, Nils. For me, it's an honor to be part of your team, international team now. And I want to say, I'm sorry for the interruption, that this is a brief first sight of the whole world related with these matters. Here in Chile, it's just a presentation of a few minutes, but I really want to show you and share with you many other details related with such matters. Okay, so I again offer you, all our helps from Chile related with such matters. Thank you.
Can I ask a supplementary question from you, Christian?
Yeah.
The only organization in the construction sector that I know in Chile is Cámara de la Construcción.
No,
Were they?
no. The Cámara of the Construction, it's a
Yeah,
private.
I'm saying that's the only organization that I've had any contact with. And
Okay. Understand. Sorry.
I'm just asking, were they helpful or a problem or irrelevant to your work?
Well, yeah, this is from private sector. It's a private association of, construction companies here in Chile, which of course it's, interest in the composition of laws and regulation and mostly related with economic issues, of course. So, my recommendation is, yes, be in contact with them, but they are not, technicals, a very good technical support for this specific issue, they knowledge, they experience is more related with real estate development or something like that. Nothing more. So my recommendation is to be in contact, for example, with EDM, which is this certified institution by Universidad de Chile, or the DIC-DUC from the Pontificia Universidad Católica. These two laboratories are, the huge amount of experience, so many tests, so many exams, so many proofs, during 50 years or something like that. So this is my recommendation to you. So I will put in contact you, of course, of them, after this meeting.
Yeah. Not for me so much, but for Ilker and his Turkish colleagues. Yes.
Yeah. Well, of course, we are working with them all the time, so it's as a part of our team in some way.
Okay, thank you.
No, thank you.
I want to add one more thing. During your presentation, you told us that every earthquake is unique. So after every earthquake, we learn something, and that's the reason why in your country you changed the regulations a little bit, I guess. Now it is time for us. A very big earthquake hit Turkey, so now we are discussing about the regulation. So it is time to learn to which way we have to go and which sites we can change. So that's the reason why this presentation and your knowledge in your country is very, very useful for us. For that reason, I just want to thank you again. Anyone, any questions from the audience here?
Yes, related with your commentary, Ilker, I think it's a wonderful point, because Chile is more related, with your country as a many factors, because we are not German, we are not Germany, we are not Switzerland, or we are not, I don't know, in the United States. We are a poor country with many problems like you. So I think, of course, so many differences between us as well. But in the sense of cities, in the sense of the way to avoid corruption, etc., our process, I think, and I really believe it probably will be so useful for you.
I'm
Because
pretty
it's
sure
more close. It's more close to you.
I'm pretty sure
more-
about it.
It's more affordable or something like that.
Anyone? Who
May I say that was an excellent presentation from both of you. I'm very grateful to be participating here. And I would simply like to broaden the discussion ever so slightly. What we are talking about is the housing delivery system in the country. It is very important to keep an extremely open mind regarding who should be doing what to whom at this particular moment in time. It could be a university system. It could be a national research council, as we have it in Canada. But what is important is that it is a scientific authority.
Yeah.
It is a place where when somebody says this particular cement block can withstand this kind of force, the entire industry knows that that is true. So what we are hunting for is not the relationship between a particular university or another. We are hunting for a scientific authority, which is the activity that must be fulfilled in order for this hierarchy to be delivered to the individuals in the field. And that hierarchy also includes training and education. It includes inspection. It includes warranty. It includes the insurance industry. And of course, it includes the builders as well. It's a pyramid. But at the top of that pyramid, as Christian has very accurately identified, is the scientific authority from which all of this flows. Now, how that will be ultimately put together in Turkey will have to take into consideration how things are currently organized. But what is important is that we find the pieces of the puzzle, regardless of what they're named or where they come from, so long as they remain independent of the people whose material they are testing. That is the key to the whole thing. So forgive me for being pedantic. I merely wanted to say that it doesn't matter if it's the university system. What we are hunting for is a scientific authority. And I will send around a little note indicating what the other bits of that might be. Thank you.
Oh, thank you for your commentary, because it's true, it's completely true. But the culture here in Chile, where scientifics are in Chile is in the university. So this authority, scientific authority is contained in the university. So the university is maybe one of the powerful authorities in our country. So you are completely right. Thank you very much indeed to reinforce this idea.
I have one more question. I don't want to disturb the others with my questions. But as far as I understand, you also mentioned about the soil quality.
Yeah.
So it's a huge country. Our country is also huge. And understanding the quality of soil, and you have divided the country into pieces related with the soil, if I understand right. So those examination, taking the soil, the tests takes too much time, and it depends on how many meters you are going for the test, 30, 100, and we are discussing about 300 meters to take some tests, etc., from the soil. So I just want to learn how you can combine.
Well, this is an excellent question. Because, for example, one of very nice things about this regulation is that moving all the time, moving related with the earthquakes, moving. So maybe 5 years ago, the limit between some zone and another was quite different. It's moving down. First of all, so you must to review continuously, always. So the second thing is that it's very specific. So the regulation it's how is the word? The regulation impose you. It's like a very imperative thing that very specific conditions in that soil. So municipality, extend and inform related with a specific piece of land. And in this, official inform of this piece of land appears, the quality of the soil, the classification of the soil updated, and also the requirements to test this soil. So, for example, here in Santiago, just in Santiago, in the main capital, you have represented in one city the 6 zones already existed around the country. So if you go to this town, appear the zone 5, and through another town appear zone 3. So it's so different, and the construction related with the foundation, for example, is more cheaper or more expensive related with the soil, but not the soil like real estate things. No, the soil for foundations. So in this sense appears different requirements related with your foundations. So for example, here in Santiago de Chile, there is the most higher building in Latin America, which is the Costanera Center. It's around 90 storage buildings. It's a huge 330 meters high or something like that. And all the structures, are designed by a floating foundations, and with some researchers, this repliers, and so this foundation was provided, and imposed you by the regulation of this piece of soil. And if you take, the neighborhood of this piece of soil, appear probably a complete different type of soil. So this is very important. In my very humble opinion, the damages related with the buildings, for earthquakes are in a maybe 75 or 80%, as a result of a bad decision with the consideration of the zone of the soil and, of course, the requirements for its foundations. So this is very, very, very specific. It's very important. So in your country, probably it's the same. The difference, between soils and difference of different requirements related with the foundations, maybe is a key issue. When I saw some pictures, if you saw my presentation, it was without pictures of the destruction. This is a rule for us. Not show destruction, no show dead people, even related with our works for Irpin city. In Irpin was the massacre of the civilians, we did the project for the memorial of this massacre. So it was very difficult to explain that, you don't need these pictures. You must, focus on the scientific factors. You know, this is the thing. So, for example, another thing related with these 40 buildings, you know, were collapsed in our last big earthquake. All these buildings collapsed, of course, but in the way of this collapsing process, you know, allowed people, the majority of the people, to get out immediately. You know, it's related to the time and how the structure rings. You know, how the format is by design, a structural design. So it's not like your buildings, like, you know, in this way, or in the Mexican big earthquake in 1985, you know, the same, victims, because buildings, you know, in this sense, you know, transform itself in a trap for this kind of thing. So the regulations is not to build, you know, powerful buildings, you know, very expensive building. No. It's a very smart building that, you know, permit the suffering of materials, etc., but never collapse in such a way that, you know, kill people in this way. So, for example, you know, in the how would I say, the most known collapsed building in this earthquake appears my friend history with died because of a heart attack, not for the concrete smashes. You know, it's so different. And from 525 victims of this earthquake and tsunami, only 525, you know, more than approximately 6% of these victims were related to the tsunamis, alarm failure, nothing more. So if you see people who die because of the effect of collapsing structures and etc., I think it was 80 people, 75 people or something like that. I don't remember the specific date, but it's marginal, you know, complete marginal. So this is the thing, you know, soil regulation, you know, structure, design regulations, and of course, you know, the procedures and process of construction, certified materials. So this is the key issue in our example. But in my humble opinion, you know, as I repeat you, the soil has a very, very important role, you know, in such matter.
Thanks a lot, Christian. One more question. If someone wants to ask, I can stop here, or otherwise I want to ask one more question. In your country, you are using reinforced concrete a lot, I guess, right? And it is the typical construction system is reinforced concrete frame structures, right?
Yeah.
And what about timber?
I'm sorry, but this is not the best construction, you know?
I know.
The best construction in Chile, you know, with a high avant-garde technology is by wood. You know?
That was my question.
This is our material to the future, you know? We have a huge amount of forest surface in the south, you know? And we have three biggest and international, you know, companies. We are trading this forest, you know, very renovated process and etc. And development this technology related with laminated wood plates, you know, it's spaced between them, and is the same resistance of the concrete, you know, and the same resistance and retarding the collapse for fire. So it's amazing. And for example, our projects for Ukraine, all of them are constructed by this material, new material, you know. So concrete is expensive. It takes a long time to be dry. so it's expensive about the process of the construction. And concrete has the problem related with the oxidation process of the steel bars, you know. So this is another big issue, you know, in the construction process, because when you are not using the steel bars, what is the way that you are protect it from the oxygen, you know, oxidation? So this is another issue. So the risk related with the oxidation of the steel materials here in Chile is another big issue, because we are a lot of, you know, surface related with the sea. So the sea, you know, or salt, breath, etc., you know, corrupted completely the steel bar. So here, the principal material in order to avoid earthquakes and etc., is the new technology of the laminated wood.
Thanks a lot. In fact, that was the important part for my question, and you answered in that way.
I'm sorry, you know, I'm sorry. One example of that, this is a very good thing. Now, in the south of Chile, there is a company building a 12 storage building by this material, by wood. 12 in Chile with big earthquakes, 12 storage building. I can show you in the next presentation. It's wonderful. The same technology from, you know, Nordic countries, but with our experience and reinforcement of the structure by our experience of the earthquakes.
We will be very happy if you can show some examples of that 12 stories building, because we have two experts here who are dealing with constructing with wood in Turkey, and we are having meetings with them. They have a deep knowledge about the using wood, and we have a new regulation, and you already met Ahmet Türer Hoca. He is in charge of the regulation, and hopefully we will have a chance to use wood more and more in our country, but we need experience from a country who has earthquake problem also. So the countries which are using wood, they don't have earthquake problem usually. So that example can be very interesting for us also. Thanks again.
That is it. That's it.
Any other questions, or can we move to the agenda of the meeting and we can close the YouTube part? Yeah. Do you have any comments or questions to Nils and Christian? Very interesting and powerful presentations. I guess not. Then Melis, we can stop sharing YouTube according to me, and then we can discuss about the workshop and seminar series which we want to have in Turkey, Izmir. For the ones who are watching from YouTube, thanks for watching, and the YouTube page will be there for a long time. So anyone wants to have a look at it, it will be there. I will share the link with you all people here.